Now we are going to see some fundamental functions. The first one that we'll see is the constant function. Students, here you can identify the function by its name. See, it says constant. Here f r to r given by fx is equal to k, where x belongs to r and k is a constant, is called the constant function. K is a constant, means it is a fixed value. Here from the graph you can clearly see this is the y-axis, this is the x-axis. Here we have the values 1, 2, 3, 4. This is the positive side of x and this is the x bar, which is the negative values 0, then -1, -2, -3, -4. On the y-axis we have 1, 2, 3, 4, 5 onwards, and below that we will be having -1, 2, 3, 4. Here if fx or y is equal to 3, this will be a straight line parallel to the x-axis. Here the domain will be -infinity to infinity. Here you can see the values are going to be at this point it is -2, 3. At this point it is 2, 3 likewise. So the range is 3. Next is the identity function. Identity means identical or like. If the domain or codomain are same as A, then we define a special function as the identity function, defined by fx is equal to x for every x belongs to A. Let us assume that let A is equal to r. Then identity function f r to r, where y is equal to x, is shown in the graph in this figure. Graph of fx is equal to x. See, identity means same or identical. So fx is equal to 1. Okay, x is equal to 1, then y also will be equal to 1. 2, here also 2. When you keep pointing on the graph, when you join those lines, you will get like this line passing through the origin. So this is the graph of the identity function. Here the domain is -infinity to infinity, and range is also identical to the domain -infinity to infinity. Third is the linear function. A function f r to r of the form fx is equal to ax plus b. When you get question in this form, it is a linear function. For example, fx is equal to -2x plus 3. The graph of this is shown in this figure. See here. Domain in this type of questions is -infinity, infinity, and range is also similar, -infinity, infinity. See, this is the graph. When you put the values of x, you will get such a linear graph. Properties we can see over here is graph of fx is equal to ax plus b is a line with the slope a. Y-intercept is b and x-intercept is -b upon a. This graph is increasing when the slope is positive and decreasing when the slope is negative. Fourth is the quadratic function. We all know what is a quadratic equation. So when the function of the form fx is equal to ax square plus bx plus c, where a is not equal to 0, this is a quadratic function. This is a graph of a quadratic function. This is the y-axis, this is the x-axis. This is the quadratic graph. Here the domain is -infinity, infinity, and the range is k, infinity. The fifth function is function of the form fx is equal to a x raised to n. n is a natural number. Note that this function is a multiple of the power of x. Okay, for example, here we have the square function. Fx is equal to x square. This is the graph of a square function. For example, if we have x is equal to 1, then x square will be equal to 1. So here x is 1, then y is equal to 1. If x is 2, then y will be 2 square is 4, 3 square is 9, and likewise. Okay, so this, when you join these points on the graph, you will get such a curve. Here the domain is minus infinity, comma infinity, and range is 0, comma infinity. The second type of function under this concept is the cube function. Fx is equal to x cube. For example, cube of 1 is 1, cube of 2 is 8. Okay, then cube of minus 1 is minus 1, cube of minus 2 is minus 8, and this can go on. When you join these points, you will get such a graph. Here the domain is minus infinity, comma infinity, and range is also minus infinity, comma infinity. The sixth fundamental function is the polynomial function. A function of the form fx is equal to a0 x raised to n plus a1 x raised to n minus 1 plus, and this will go on till a n minus 1 x plus an is a polynomial function of the degree n. If a0 is not equal to 0 and a0, a1, a2 till an are real, the graph of a general polynomial function is more complicated and it depends upon its individual terms. Graph of fx is equal to x cube minus 1 will be equal to fx is equal to x minus 1 in one bracket into bracket x square plus x plus 1. Cuts x-axis at only one point, 1, 0, which means fx has one real root and two complex roots. See, this is the graph. Note that any polynomial of odd degree must have at least one real root because the complex roots appear in the conjugate parts. Okay, see, this is the graph of x cube minus 1. Complex numbers are numbers which have imaginary numbers. Okay, so conjugates are when you inverse the sign of the complex number. Okay, so the complex roots appear in the conjugate pairs. The next one is rational function. Definition is given polynomials px and qx. When you put it in the numerator and denominator form, this is the rational form. Fx is equal to px upon qx, where qx is not equal to 0, is called a rational function. For example, if we have fx is equal to 1 upon x, then this is the graph. Your domain is 0, but here you see there is a minus sign, and range is also the similar. Here domain of the function fx is equal to 2x plus 9 upon x cube minus 25x, that is fx is equal to 2x plus 9 upon x in bracket x minus 5 into bracket x plus 5 is r is equal to 0, 5, minus 5. As for x is equal to 0, x is equal to minus 5 and x is equal to 5, the denominator becomes 0. The eighth function is Exponential function. Exponents means here we have a base, a number, and the power is a variable. A function f r to r plus given by fx is equal to a raised to x is an exponential function. Here the base is a and the exponent, we can also call it the index, is the x, the variable. But a is not equal to 1 and a is greater than 0 and x belongs to r. This is the graph of the exponential function. Here the domain is r and the range is 0, infinity, also called as r plus. After that we have the ninth function, the logarithmic function. A function f r plus 2r defined as fx is equal to log a x. Here a is the base. A is greater than 0 and not equal to 1 and x is also greater than 0, where y is equal to log with the base a x, log x with the base a, if and only if x is equal to a raised to y, is called a logarithmic function. See, y is equal to log x with the base a. This is the logarithmic function. This is equivalent to a raised to y is equal to x. Here what happens is this base shifts to the opposite side and y becomes the power and it is equal to x. This is the exponential form. Here are a few rules of logarithm. First is log AB with the base m, that is equal to log A with the base m plus log B with the same base m. So when there are two different logs which are in multiplication, then you separate it and add it. The opposite is when you have log A upon B with the base m, then log A minus log B. Okay, division becomes negative, that is minus, subtraction. If you have log A raised to B with the base m, then what happens is B comes outside, the power will come outside, it will become B into log A. For this change of base formula, here you see the m is the base. For A, x, B, all should be greater than 0 and A and B not equal to 1. Log x with the base A, that is equivalent to log x with the base B upon log A with the base B. See, here you have changed the base from A to B. Note that log x with the base A is equal to log x with the same base x upon log A with the base x, equal to 1 upon log A with the base x.